And thank you, everyone. Got it. All right. Thank you, everyone, for joining us today. What a great audience to have on a warm August Friday AI seminar. So love the AI seminars. I've been going for years. My name's Gail Powley, President of Technology Alberta, and I'm very pleased and honored that the AI seminar has allowed me to introduce a new company that's using AI and ML in the Edmonton or Alberta area every month. And love the fact that Darkhorse Analytics is with us today. For everyone in the audience, the majority of these companies are actively hiring and developing products. So please do not be shy with linking in with the companies and inquiring about opportunities. And we overall, on a Technology Alberta waving the flag standpoint, we want to keep great talent here in Alberta. And working for companies like Darkhorse Analytics is a wonderful way to go. So without further ado, I'll invite Daniel to tell us more about Darkhorse Analytics, what the company does, and opportunities that they can provide. Daniel.
Thank you very much, Gail. I will start out by just giving a bit of a story about Darkhorse and who we are and where we came from. I know many of you, and I appreciate the different perspective offered by people from the Amii, ML, computer engineering, computer science side. I always tell young students that you should probably drop out of school if you're planning to start a business, because it's better to not know what you don't know. And because if we really knew what we were in for, we probably wouldn't start a company. So it's good to be a little bit naive to do so. And my co-founder, Joey, and I, we were both business school grads, and we were working at a research lab doing management science at the U of A. And we decided, hey, let's start a company. This can't be that hard. And somehow we stumbled into it, and we realized that we need someone to understand the technology side. So we made a whole bunch of mistakes hiring people. We hired one guy, brought him in to be the CTO, and we brought someone else, and he hired someone else, or we hired someone else from computer science here in Edmonton. And the CTO came to us and said, you know what, this guy's really not working out. We should let him go. So I'm like, okay, you're the CTO, you know what you're doing. So we fired that guy. He went on to become a very famous Microsoft researcher. He's written a book. He's very famous. The CTO himself, we had to buy him out because it didn't work out. So we learned a lot of really hard lessons about what we didn't know about technology and programming and so forth. But now most of our team comes from computer eng or computer science at the U of A. And we're quite excited and have learned a lot more than we did know. So speaking of team and Darkhorse, we're a local Edmonton company, although since COVID started, we started hiring remotely. We now have employees in Ottawa and Kelowna and Calgary and Canmore. And really the limiting factor seems to be time zones, keeping them close enough so that we can talk without staying up late. But we are hiring those who are interested in working with us. We do two main things. On the one hand, we have built software for public safety. We basically took a bunch of research done at the U of A it was called the Center for Excellence in Operations. And it was research in public safety, optimizing the locations of ambulance stations and vehicles. And we licensed that technology and built a software tool set, and now eventually a whole software division around that. Our clients include the Toronto Fire Service, Vancouver Fire, Hamilton, the Greater Salt Lake, etc. And these people pay us every year to use our software to help them do planning and data analytics for their departments. And it uses, I wouldn't say it's AI, I guess it depends on how you define AI, but it uses linear and nonlinear optimizations and heuristic methods to actually place vehicles and stations and so forth in an optimal way or a near optimal way. So that's one half. about halfway into our journey, Darkhorse started in 2008. We started working for a local professional hockey team, whose name rhymes with spoilers. And I used to go to bed at night, and then I would wake up and I would be nervous that they were going to do something stupid. And I ran into this problem that, we were advising the GM and the coaches, and I even got to present to the players, what is analytics? It was kind of fun. But I was always afraid that, I have the right answer. I know what they should do, and they just won't do it. And eventually things started to change. But I had this epiphany, and I realized that, this old adage that you can lead a horse to water, but you can't make him drink. I'm like, hey, I've done my part. I've shown them the right answer. My job is done. And I had this epiphany that maybe my job doesn't stop when I present the right answer, but my job stops when I convince them that it's the right answer. And that changed everything. It changed how we approach problem solving. We would involve them in the decision-making much earlier in defining the problem. We'd, help them understand along the way. We built models that were much more transparent, much simpler, probably much less precise, but much more effective in the end. And so that was a kind of a sea change. But one of the other things we developed was an understanding of the power of data visualization. And so about half of my talk today is going to be about data visualization as a means to convince and engage your audience. So that's back to my initial point here. The other half of our company does data analytics and visualization with a heavy emphasis on the visualization, or you could call it visual analytics. And the majority of our clients end up being foundations or NGOs based in the US who, typically it's an academic or NGO that has come up with an idea that they're trying to convince policymakers to adopt. So it might be, hey, we have a new way to measure poverty, or hey, we want to fight fake news, or hey, we want to, help people understand COVID. And they have an angle, they have research that supports this, but they need to be able to connect with and engage those decision makers. And so that's what we do with the data visualization. Sometimes we help them do the analysis. And again, our background is very heavy on the analysis, but that allows us to create visualizations that are both clear and engaging. And that's what I'll talk about later on. But first, let me jump into the overview of the topic today. I said the ML, the AI, the analytics is the meat in your burger, but what allows us to eat the meat is the bun. And also some of the garnishings help out as well. So I'm going to talk mainly about the buns. And I describe the two buns as data wrangling at the front end and data visualization at the back end, and how those will allow your models to be more effective and more accessible to a wider audience. So I see on the chat, just want to make sure there are not any. Randy was actually there at the very beginning and instrumental in getting us involved on that Oilers analytics group. And that was a lot of fun. Sadly, this stat rings true, even with the Oilers. 70 to 80% of analytics projects fail. They fail for a number of reasons, and I'm going to talk briefly about a number of those reasons. And when you see the word analytics, that was the buzzword when we started our company. That's why we're called Darkhorse Analytics. The buzzwords right now are machine learning and AI. So you can just kind of swap those in your mind if that helps. But this is a pretty damning stat that up to 80% of these analytics projects fail. And they fail for a number of reasons, because there are a number of failure points. And at a very simple level, there are 4 stages or steps that go into successfully developing an analytics solution. You frame the problem, you wrangle the data, you build your model, and you present. And this is what we would tell our students, hey, let's go through these 4 steps, and these would be 4 modules in a course. Now, the truth is, we like to do all of our research on this big one, the modeling one. It's no fun to do research on data wrangling or presenting or problem framing. And so what most of our students graduate with, I say our students because I still teach one course at the U of A. Most of them gravitate to modeling because that's where all the fun is. That's where the excitement is. That's where the publications are. It's the new algorithms. It's the faster algorithms. It's the better approaches, the more precise models. So this is what our students are exposed to. But in the real world, this is what it looks like. An actual project is 80% data wrangling. And I'm not just making that up. If you poll data scientists, they will admit that 80% of their time is spent wrangling the data. Probably about 15% of the time is spent problem framing, and 5% of the time is on modeling itself. Now we're already out of time and you're over budget and you don't have any time to present or think about how to present. And that's where the data visualization falls in. But notice that these arrows on the bottom, I put them there to demonstrate that this is not a linear process. What typically happens is you start framing a problem, you start playing with the data, and then you realize the data doesn't support what you're trying to model. So you go back and you reframe the problem and you start again, and then you wrangle some data, and then you start building a model, and then you realize that it's just unsolvable, or the modeling approach you came up with is wrong. And so then you go back and you frame the problem again, or you wrangle, you realize that there are data errors. So you have to go wrangle some more. And then you go back to do some more modeling. The worst case is when you're presenting to a client or a stakeholder and they point out that your data is wrong, or that you've solved the wrong problem, or that the modeling has errors in it. And then you have to go way back again. And I've experienced all of these things. I'm sure many of you have as well. So I'm going to touch briefly on each of these stages and what I see as the most common problem in each. And then we can talk about details around the wrangling and the presenting side, all right? So I would say one of the biggest problems, and I put this as number 0, falls under the problem framing one, and it's not measuring success. And I have another damning stat. Actually, I don't know if I put it in here. A poll of data scientists found 4% could answer this question with the affirmative. I have been able to demonstrate the value of an analytical project to my company. Only 4% could say yes. So we do a lot of analysis, we do a lot of modeling, but we don't measure success. And that comes by doing it this way. I call it the MAME. We want to MAME it, not kill it, right? So we want to measure whatever we're trying to improve. Then we do our analysis. Then we do our intervention based on that analysis. Then we measure again. And no one is doing the first measure or the last measure. They're doing the analysis. Maybe they're doing interventions, but they're not showing how what they've done actually improves things. And so that's something I even our team is guilty of this as well. How do we know what we're doing is effective? Well, let's start measuring something that we think is going to improve or decrease or increase before we start doing the analysis. Then you have something to point back to. All right. Oh, wait. Yeah. So sure enough, that stat was from Harvard Business Review. 4% of data scientists produced measurable results in the previous year. It's the measurable that's the problem, right? So then there's another problem. And I kind of alluded to this, solving the wrong problem exceptionally well. And I'll give you an example of this. We were asked by a school division in Alberta to help them optimize the school bus routes, because school buses are very expensive. It's about $50,000 per year per bus to run a bus. And they never run at 100% capacity, right? And perhaps if we changed the routes that they took, we could come up with a routing scheme that would reduce the number of buses we need. But they told us, hey, we can't have the average drive, we can't have the ride times increase. So you have to keep those ride times very close to the similar. So we came up with a multi-criteria objective function and an heuristic that would come up with different routing schemes. And we iterated on it over and over because we'd come up with a solution and they say, oh no, the bus can't go down that alley, or oh no, the bus can't turn left there, or oh no, we don't want the kids to run across that busy street to get on the bus. It's got to be coming the other direction. And so we did all kinds of work, reformatting and changing the input data and changing the algorithm. And then we came up with these routes that actually reduce the number of buses they need by 10%, and at the same time, improve the average ride time by 2 minutes. So think about that. We had fewer buses and shorter average ride times. You would think, man, they would be jumping up and down with joy. We were saving them, and it was a small division, so $100,000 per year. So for sure, they're going to do this. And did they do it? No, they did not. And they didn't even tell us why. And it wasn't until quite a bit later that we realized our error. And that was that, imagine you're a parent and you have a child, and you're used to getting your kid on the bus at 7 o'clock, and you hop in your car at 7:05 and go to work because you need to be there at 7:30. And now suddenly, although the average ride time has not changed, your kid is riding on the bus in the morning only 10 minutes instead of 45, because some other kid is riding 45 minutes instead of 10. And so, my kid is no longer getting the free childcare on the bus, and I have to stay home till 7:45 before they get on the bus, and I'm late for work. Or, I happen to be the principal's daughter, and I'm getting on the bus at 7 a.m. and my mom is very unhappy that I have to get up so early. So of course those routes are not going to be accepted. So our objective function was the wrong one. We needed another criteria in there that said, similarity to current, or no student shall change more than 10 minutes, or something like that. If you are the transportation manager, 90% of your job is fielding complaints from parents, 10% is building new routes. So of course, you're not going to take on routes that are going to generate more work in that 90%. Anyway, I digress. So solving the wrong problem extremely well. We mess up the data wrangling, and I'm going to go into detail on this, but let me just give you this quote. The only clean data you have is data where mistakes would send you to prison. People say, oh, our data is great. Data is really clean. That's just because you never looked at it. And we'll talk a bit more about that. You can mess up the analysis, and I'll just give you, I'm sure none of this is going to be new to any of you, but I think these are some great pictures of how you can mess up the analysis. And my favorite one is when we confuse correlation and causation. Here we have the map of Virginia is a dead ringer for the Shanghai composite during that time period. But my favorite ones have to do with health and nutrition, because most companies don't brag about the mistakes they make in analysis. But what I love about academics is it's all public, and we take great pleasure in exposing the mistakes of other researchers. And so we've all gone through this. We grew up, eggs are nearly as bad for us as cigarettes. Bacon is as deadly as cigarettes and asbestos. I call this the war on breakfast. Started in the late 70s. Hold the eggs in butter. Cholesterol is deadly. Our diets may never be the same. And don't you dare put salt on it. It kills more people than the Vietnam War every 4 months, right? So you get the cover of Time magazine, looks something like this. And then wait a few years and we get this. Hey, by the way, we were wrong about butter. Sorry about that. Oh, you know what? Saturated fat and heart disease. Actually, there's no link. The story behind this is fascinating. If you ever want to read a whodunit about the battle that happened in the 60s between this very famous physician, Ansel Keys, and his arch nemesis in England, who believed in the sugar theory of heart disease, and how the Ansel Keys was closely connected to the president of the United States and was able to vilify and basically end the career of his archenemy and completely shift the focus onto saturated fat, how he kicked out a few of the outliers from his analysis, which happened to be Germany and France. And so instead of the 9-nation study of heart disease, which would have shown no correlation with fat intake and heart disease, we have the 7-nation study, which shows a perfect correlation. And so forth and so on. And my favorite part of the story was this is back before the invention of consequences, back in the dirty 70s and 60s, and ethics. And they took retirement centers, prisons, and insane asylums, and they swapped them out of butter and saturated fat. And they said, corn oil is all you get from now on. And they measured the cholesterol level before and after, and they said, look at that. It drops instantly when we switch to corn oil. Clearly, this is the smoking gun. And it became the policy and the food guide and all the rest. And heart disease rates and obesity and diabetes kept going up and up and up. Like literally the inflection point is the year the food guide came out, which was the year that all hospitals and prisons and schools had to follow the food guide. And it took some very courageous scientists to eventually dig a little deeper. And one of them was I think a TA who was involved in that original study. And he pulled out the original data from those insane asylums and such. And he said, what if we change the endpoint? Instead of looking at cholesterol levels, what if we looked at deaths from heart attack, since that's what we're worried about? And guess what they found? Not only did deaths from heart attack not decrease, they actually went up when they switched to corn oil. And not only that, but deaths from all kinds of other things went up. Deaths from cancer went up. Deaths from all kinds of things went up as soon as they switched to corn oil. So this whole vegetable oil thing, don't get me started, actually already did. It was very, very unfortunate and probably resulted in many, many lives lost. And it gets worse. They found the same thing with salts. And then we get the cover of Time magazine that says, by the way, we are actually wrong about cholesterol for the most part. So this has spread, and you've probably heard of the crisis of reproducibility that has begun to infect various parts of academia. This is Amgen, where they said, we're going to look at all our drugs that have been approved by the FDA and see if we can actually get reproducible results, which is a nice way of saying that the drugs actually work or not. Like, does the placebo win? And Amgen found out that when they retested their drugs in a new double-blind study, 9 times out of 10, the placebo wins. Bayer said, hey, we better check ours out. And they found actually 3 times out of 4, the placebo won. So they're doing a little better than Amgen. And this has spread even to psychology, and some of the more famous studies that we read about in popular books have been proven to be false. The one, willpower depletion, I think was an interesting one, where they found that the kid who could resist, this is if I resist a cookie in the morning, I burn up so much willpower, I might say yes to the crack cocaine in the evening. And so what they found was that the way the study was done was they had 2 groups of students, or they came from 2 different areas. They were either the children of Harvard professors, or they were from the low-income neighborhoods immediately around Harvard. And sure enough, the kids who came from low-income neighborhoods, who often were hungry, weren't going to say no to the cookie, because they were used to growing up in home where dad said, don't worry, son, I'll be home tonight and bring the cookie. And dad never showed up with the cookie. So they knew and had learned that you took the cookie and ate what was in your hand. So really all they found was that kids who grew up in low-income families have poorer outcomes than the children of Harvard professors. No surprise there. And then it kind of gets worse. Basically, up to 90% of the published medical information your doctors rely on is flawed. And when you present this to physicians, and this has been kind of a number of conferences around this, they say, you know what? This kind of aligns with my clinical experience, because I would read the paper that would say that this particular drug should cure this particular condition, and I would be giving it to my patients, but it felt like I was giving them nothing, or it felt like it was actually worse than giving them nothing. So people were not resistant to this, and it started a slow change. Now you have to register your studies beforehand. There's all kinds of ways that this sneaks in. All right, so enough of the bad news. That's how modeling goes wrong, and I'm sure that's no surprise to many of you. Let's talk about presenting. This is the problem of the oracle, right? She can see the future, but nobody believes her. You are a researcher, you're an analyst, you come up with the right answers, and the Oilers still trade Jeff Petrie for peanuts, and now he's a star on a Stanley Cup Finals team. So how do you fix that? how do you convince people that you're right? So in short, I'm just going to talk very briefly about a few ways, and then we'll talk about data visualization. So number one, you can create rules of thumb. And let me give you an example from hockey. So we did some regression analysis that took into account, who was on the ice when a junior age player scored. So we're trying to help them draft better players. Who was on the ice when they scored? Who were their line mates? Who was the opposition? How good was their team? Was it a power play goal? Did they get the first assist or the second assist? And so a whole bunch of things, throw them in and basically come up with these regression equations that were fairly predictive of success. And try presenting an R-square and a p-value to a scout who's traveling around Northern Ontario and Quebec, 8 months of the year looking at these teenagers. They don't care and they think you're an idiot, and with good reason, because you don't really know what their life is like and don't really know what you're talking about on a lot of things. And so we changed our approach and we said, what if we dumbed this model down and we just came up with these threshold rules of thumb? And so what we did was we came up with, if a player doesn't score more than a point a game in the CHL, their odds of actually making it are 1 in 100. Of the 400 kids who've been drafted like that, only 4 have made it to the NHL. So, if you find someone that looks like that, you need to have really good reasons why they should be drafted. Or if a kid doesn't score 40 goals in the BCHL, they have never made it to the NHL before. And so they could go back and they could look at it and they're like, sure enough, yeah, no one who anyone's ever drafted has ever made the NHL unless they scored 40 goals. And so instead of using the really sophisticated model that might take a kid with 39 goals and tip him over the edge and say, hey, you should take him, we just said, hey, these simple rules of thumb. And that did more to convince them and to change their behavior and to change their thinking than all the banging on the regression drum that we could have done. You can also tell stories. People learned around campfires through oral traditions for thousands and thousands, perhaps millions of years. This is how we learned. And if you can formulate your model results into a story, if you can say something like, hey, kids can grow 6 inches after they're drafted. Kids can improve their skating after they're drafted, but if they couldn't score in junior, they're not going to suddenly learn how to score in the NHL. And if you start telling those stories, like this kid was the slowest kid in his draft year, couldn't skate, but man, could he score. And sure enough, he became a superstar. Now you've created these stories that they can look back and they say, oh yeah, Jamie Benn, he was like that. In fact, he was the slowest skater in his draft class, but he became a superstar. And sure enough, he scored 40 goals. So turning and creating narratives is a powerful piece. And perhaps the most powerful type of way that you can convince people is you can create data products in a very particular kind of data product for exploratory analysis, where people can find their own truth. And I'm going to come back to this in a bit. But this is kind of the third way that you can help people self-serve the results of your analysis. So creating web apps and so forth, dashboards, BI, to help people understand the results of your analysis. All right, I'm going to stop there and look at the questions, just in case I'm missing any. It doesn't look like I am.
There's lots of good conversation. I think for a quick comment on the interesting questions. And then there was another question. Do you have to convince people to give you good baseline data?
Oh, if only you could convince them to do that. The problem is no one can get that to you. Yeah. The data is always the headache of every project you'll do. And so we do this for clients, and we're doing some natural language processing, and the helping to categorize kind of written reports into standardized reporting. Some pretty straightforward stuff, but it took us 6 months to get access to the data, let alone to clean it up, right? like getting access to data is often difficult. I think my record was 18 months trying to get access to Alberta health data for a project. This is back while I was at the university. And that was, I think, 2 ethics reviews, 2 privacy assessments, plus a bunch of other meetings and trainings and so forth. So it's getting access to data is your first hurdle, and then you clean it up. And only then do you get insights, and only then do the insights start coming. And the insights come so fast that people have difficulty absorbing what you're doing, which is, again, another argument for data visualization. All right, so I'm going to talk about data wrangling. So I consider this a public service because, frankly, you can't get a PhD in data wrangling. In fact, there are no courses on data wrangling taught by the U of A, U of C, or any other university that I've ever seen. Now, sometimes they call it, hey, we have this data wrangling course, and you can go on Udacity and get a data wrangling course. But all it is it's teaching you, here's some functions in Python to help you sort data and find outliers. Like, no one's teaching you conceptually, why do I need and how do I wrangle data? How do I deal with the systematic risk versus the random errors in my data? So that's what I'm going to talk about today. So it's not the sexiest, but it is important. So as taught in school, this is data wrangling, right? Hey, we're going to learn how to live off the land and survive off of wild deer. And here you go, here's some venison, and we're going to teach you how to cook it. That's what it's done at school. In the real world, it looks like this. You've got to go out there and make a bow and shoot the thing and butcher it before it looks even like this, right? We give these canned data sets a lot of times. Now, this is probably less true in grad school. And what I think ends up happening is people, they figure out this approach that I'm going to talk through on their own. And they figure it out through trial and error and multiple failures. All right. So none of this is going to be new, but these are the kinds of things you'll have problems with. You have problems with your data content, right? Spurious characters, spurious spaces, null values or blanks, miskeys. You'll have your outliers, right? This guy down here, why is he sitting on that wire while everyone else is up there? What did he do? And you find this in your data too. Like, what on earth is going on with this particular ambulance call that took 18 hours to respond to, or 6 months to respond to? Or is the oldest teacher in Alberta really 125 years old? Something sounds wrong here, right? And you've all run across these, and they can screw things up. If you're taking an average and you've got an outlier, that's a mess. But sometimes it isn't an outlier. Sometimes it is actual data that needs to be part of the analysis. And how do you decide, and how do you figure that out? I mean, there's whole books written on how to deal with outliers. Problems with keys, right? You're trying to join data together. You need a key. You need some kind of unique identifier to pull in. I want to combine the weather data with ice cream sales. How do I do that? Well, I join on a unique date. And so you have duplicates, you have missing keys. I almost got fired from my first job because someone sent me data and they garbled the key when they sent it back. And it took me a few days to recognize this, and I'd made a mess of things. We run into this all the time when we're trying to use unique identifiers for hockey players. We use their first name and last name and their birth date now, because Alex Ovechkin is not the same as Alexander Ovechkin. Sorry, he is the same as Alexander Ovechkin, but Sebastian Aho is not the same as Sebastian Aho, even though they were drafted in the same year. Can you believe it? What are the odds? So you'll end up with problems with your dates and types, right? You'll have dates as a text string. You'll have US dates versus Canadian dates. So 03, 04, 09. What is that? Is that March 4th, 2009? Or is that April 3rd, 2009, right? You have time changes, you have time zones, you have numbers as text, you have all these old school formats, all kinds of problems dealing with dates and types. You have problems in that most of the data we deal with was not built to be analyzed. It was built to run an application. And so when they upgrade the application, they're not thinking about anyone ever extracting the data. They're thinking of people, they're thinking of what's the easiest way for me to make the application run. I'm just going to create a new column, put a to or new on the end of it, and point the application to that new column, and that's going to be fine, right? And then you'll extract this data, and you'll have something that says, res date. What does that mean? Is that the reserve date? Is that the recent date? I don't know. And so it's difficult for you to even understand what you're looking at, let alone to make sense of it. You have data update problems. We were working with an ambulance service in Ontario, and we noticed in their data they had 0 calls between midnight and 2 a.m. every day. And like, wow, like you go a whole year without a single call between midnight and 2, and then there's kind of a bit of a spike of calls at 2 a.m. And they're like, oh yeah, that's when our backup happens. Our tape backup happens then. And so they queue up all those calls and then they show them as appearing at 2 a.m., right? So you run into stuff like that. And anything that you can see in one-dimensional data just gets way worse in 2 or 3-dimensional data. You start throwing it into GIS or on maps and it just gets way worse. And I just can't wait till we start doing space-based analytics and have to do this in 3 dimensions. So you just take it to the power of 2 or 3, is that much worse. The approach then that I'm going to present here is, this is kind of, think of this as more like craftsman style. This is what trial and error taught us. And I call it 6 steps to data beauty. So let's put ourselves in a hypothetical. Let's say we're trying to predict, I don't know, what do we want to predict? What is the cause of COVID, or how does COVID spread? Something like that, okay? So we're going to figure out whether the masks work or not, or whether the restrictions work or not. So we're going to gather a whole bunch of data. So I'm going to use machine learning to figure out whether which restrictions actually reduce the spread of COVID. So the first thing I'm going to do is gather the data. So I'm starting out on this project. The first thing I do is I collect the relevant data. So I have to cast a pretty wide net. So I need to know the case counts. I need to know the restrictions, the 2 different data sets, right? When did government put restrictions in place? Then I probably need to know the compliance with those restrictions. So maybe I get Google, phone tracking data to see how often people are moving around or leaving their homes or going to the mall. What else would I need? So those are kind of 3 big areas I would look at. And then maybe I can find some demographics to see if it's, it doesn't seem to matter for kids, but it matters for adults, et cetera, et cetera. And so I pull all these data sets, right? And so I have a whole bunch of tables of data. So what do I do next? Then, and I tell students this, and I know none of them ever will, you're going to document your sources and the limitations of those sources. And sadly, none of them ever will, and they always pay the price for this. Oh yeah, we switched from, the old IBM AS400 to this new Unix system back in 1994. And so, we go from 3 decimals or to 10 TM to 3 TM or something like that. And you start finding out these, there's discontinuities in the data. There's blanks. Oh, we had one situation where someone felt that data should have been kept private. I think it was well water data. And they felt so strongly they were the only source for this data, and they had it encrypted on a single hard drive. And rather than divulge that data, they quit. And so that data was lost forever. No one could ever get access to the data. So document. And so there was a 1-year gap in the data that we just didn't have data for. Document those sources and limitations. Then you do a quick pass through each of those different tables, right? And you're going to clean up the duplicates and the blanks and the simple errors, paying particular attention to the unique identifiers or the keys in that data. All right. So you go through and you figure out, oh, okay, yeah, this is a duplicate. We don't want that. And this doesn't take that long. You can do this in a day, probably. You're cleaning up the very obvious data. errors in that, especially paying attention to the keys. And the reason we do that is because we want to join them together into a giant flat file. Because typically the analysis you do needs to be done on a flat file. So I'm joining together the people moving around with the restriction start dates, and maybe I'm throwing in some weather data there because maybe weather is affecting things or confounding things, et cetera, et cetera. But I join it all into one giant flat file to rule them all and in the darkness bind them, right? So and that's why we paid attention to the keys. So once we've done that, now here's what separates the actual data scientists from the fakers. And that's we create new data by categorizing and calculating. Now, in the ML world, I think you would call this feature generation. In the stats world, they would call this transformations and compound variables. And in analytics, we call it new data. We create new data. We're going to combine pieces together. And I would say that this is where all the leaps are made. This is where all the giant insights are found. And I'll give you an example. Here we have two tables of data. One is the event table in hockey, which has a game ID, player ID, an event types timestamp, and the event type. So at 8:52:16 in the third period, there was a shot by player ID number 33 or 97. So, and there was a giveaway or there was a hit 2 seconds later, et cetera. Meanwhile, you have another table that says, here's the game ID, here's the player ID, and here's the start of that player's shift, and here's the end of that player's shift. And it's the combination of these two tables that allowed a huge leap in hockey analytics, because I was able to figure out that when Connor McDavid is on the ice, I don't care so much about how many shots he takes. This event table would tell me that. What I care about is, does he influence the number of shots for and against just by being on the ice, by whoever takes them? And sure enough, when Connor McDavid's on the ice, his line outshoots the opposition by almost 2-to-1. He has a huge impact on the shot share when he's on the ice, even though he may not be making them shots himself. And this became known as Corsi. And in fact, they even took it further with shot attempts. And that revolutionized the way GMs and players, GMs evaluated hockey players. So someone made the leap when they combined the two tables together and created a new data element, a new column in their Excel spreadsheet called shot share or shot differential. And they attributed it back to the player ID when they're on the ice, as opposed to when they were themselves making the shots. All right. So once we have created these new things, something really powerful can happen. We can now visualize distributions that we wouldn't have been able to visualize otherwise. I can visualize shot share and a distribution thereof, as opposed to looking at who took the shots and who was on the ice as two separate things. I'll give you another example. Let's say I'm joining together, or I've created a derivative field in my data because I have timestamps, start time and end time, so I can create a travel time field. And I also have, from an algorithm I've run on shortest path, I have an estimated distance field now. Because I have distance and drive time, I can create a velocity. And so now I have a new column called velocity in my data set. Now, because I have that new column, it will identify outliers that I wouldn't have identified otherwise. If I take a distribution of all my drive times, I'm going to have things that took 10 seconds and I have things that took 10 minutes, trips that took 10 minutes. And nothing between 10 and 10 is an outlier, 10 seconds and 10 minutes. And I'm going to have distances between 100 meters and 10,000 meters. And none of those are outliers. They're all part of a nice distribution. But I'm going to have calls, say this is ambulance calls, where when I combine those two together in that new field called speed, I'm going to have 300 kilometers an hour trips. Someone took 10 seconds to go 5,000 meters. There's no ambulance that can drive 300 kilometers an hour in the city of Edmonton. that's an outlier, and I wouldn't have identified it otherwise. So that's why we don't deal with outliers until we've created the derivative data. And the truth is, this is an iterative process. You're going to come up with ideas for new features, for new data all the time. But then the first thing you do once you create that new field is you visualize the distribution. You don't run summary stats on it, you visualize it. Show me the histogram, all right? And then you see things like this. These are Polish test scores. What do you think the passing grade is? I mean, it's pretty obvious. It's 20. I don't want this kid in my class anymore. So I'm going to bump up that 17 to make it a 21. I don't want, right? Oh, he got 16. I just can't bump it up. Sorry.
Or you feel sorry for him and you want him to pass.
Yeah,
I think that's
tried
the good
hard.
thing.
She worked her butt off. We're gonna get her out of this class. All right. And you notice anything on this one that sticks out as problematic? These are call center call times. Give you a hint. Something going on at the 0, right? So this teaches me, here's a beautiful thing about doing these distributions. This is teaching me about the business. And so when I start asking questions about why do you have so many 0 calls, like calls that lasted for 0 seconds? And the answer is, Scott has correctly identified purposely dropping calls. If you are a call center operator, you are judged by your average call length. How do you get your average down? Oh, I just had a 10-minute call. How do I get my average down? Hello, hang up. I hang up that call and that brings my average down to 5 minutes. So we're seeing issues in the data that are describing things about the business that we may not have known. All right. So I'm going to go through and I'm going to take a distribution of every single variable in my data. And I'm going to see where things look funny, like we just saw in those two distributions. We see, that Polish test course thing. We see something very similar in ambulance drive times. Ambulances are judged by, did they get there before 8 minutes or not? And you see a huge spike right leading up to 8 minutes and then a huge trough right after 8 minutes. And it's them, you know what? I think I see it. Yeah, we're there. Click the button. We arrived, and drive the next, 3 blocks to get there. All right. So distributions help you understand what's going on. Here's another one. We were looking at all the education grads in the province of Alberta by gender. And you see something that looks a little fishy here. Again, I'll give you a little hint.
1999.
What happened in 99? That was Y2K. Did people think it was the end of the world? And all the men are like, it's time to go into education because that's where the wives are. We got to go quick. No, it turned out that the U of A swapped the M's and the F's for whatever reason that year. And so when you roll it all up, it kind of looks like it might be okay, but really it isn't. All right. So I'm looking at gender versus year. I'm looking at the crosstab of every single pair of data elements. That's how I find the problems in my data. That's how I learn about the data set. All right. We can do the same thing with hockey. I can combine save percentage and look at it versus points. Does it make sense that teams that have better goaltending tend to do better, get more points, and the color shows us whether or not they won the Stanley Cup? Sure enough, it does. Better goalies makes a difference. Number of hits, hit differential doesn't seem to make a difference. If anything, it's probably worse. So look at the distributions, do scatter plots, do crosstabs of all your pairs of data elements. And from that, you will find all the issues in your data. And then something else might happen. You might actually solve the problem that you are trying to build your machine learning model on. You might get to the end of all of this, all your cross-tabbing and your scatter plots, and you might realize that, oh my goodness, masks work, but restrictions don't, or 6-foot distancing doesn't, just by doing something very simple. And you don't even need to build that high-end machine learning model after all.
Quick time check. You have 5 minutes.
I have gone way too slow. So I'm going to jump over some stuff. So anyway, this is, again, my summing it all up. These are the steps I suggest people take in wrangling data. I'm going to talk a bit now about visualization. I'm going to say that visualization, it's helpful to look at it across two elements. There's clarity, which can be measured by how quickly do I say, oh, I get it. And then there's engagement, which can be measured by how long I stare at it enthralled, or how quickly I share it on Facebook, or how much time or how much insight I gain from it. All right. And you can think of this on a spectrum. There's a bit of a trade-off. I can make something very clear, or I can make something very engaging, but I lose some clarity to make it engaging. And so this would be a very clear chart, right? On-time delivery changed by 24%, utilization rate up 12%, etc. And I would put that on the clarity side of the spectrum. And then we have this Formula One infographic. And I could probably stare at it for half an hour and I still not have any idea what they're saying. Maybe I would, maybe I would understand it. I'm going to put that way over on the engagement side, right? Very engaging. It's going to take a lot of time. It's beautiful. It's pretty, very detailed. All right. But in reality, I don't think it is a continuum. I think it's more like an efficient frontier, and that there's a bit of a trade-off between clarity and engagement, but you should always be trying to make your visual presentations somewhere along this line where you're maximizing both clarity and engagement. So we created a visual of New York City, and this got millions of views. It actually crashed our website when we launched it. And all it is showing how people move back and forth between work and home, orange being work, blue being home. And you can see the financial center, and you can see people are getting there very early in the morning, and they're staying there till pretty late, 10, 11, midnight, and before they head home. All right. This very engaging. So we put it over here, but it's not that clear. There's not a whole lot of clarity you can get from that. You can't make any decisions from that picture. Does anyone know what this is? It's one of my favorite visualizations. This is someone pushing a bicycle on a flat surface 100 times. Sometimes it turns left, sometimes it turns right, et cetera, et cetera. And this is very engaging, but it has some clarity in it as well, right? And so I'm putting it very clear what it's telling me. And you can see, you know, how often a bicycle kind of makes 4 swings side to side versus 3 versus 2, right? Here's an ugly one. This is terrible, right? This is off of the frontier. It's not that engaging, and it's really unclear because the numbers don't even add up. This is supposed to be some kind of pie chart, but they don't add up to 100%. And really, you know, what's going on there? Here's another example, trying to make it engaging by making pie, but they're missing out. And so I suggest that you try to get towards that efficient frontier. And if you'll bear with me for a few moments, I'm going to give you 4 ways to improve your visualizations. First, get rid of all the extra stuff. No more 3D, no more drop shadows, no more grid lines. Don't bold everything. Get rid of the borders. This is Edward Tufte's data ink to total ink. Data ink should be the majority of the ink, or data pixels should be the majority of the pixels. So yes. Focus on the data. Don't focus on the extraneous stuff. So we take this ugly chart and we make it nice by just taking stuff away. All right.
Just a comment on that, Dan, as everybody should read the Tufte books. This summary of this is no duck. And when you know what no duck is from Tufte, you will have mastered data visualization.
All right. That's very, very good advice. You can do the same thing on your tables. We get the Excel default, which is this hideous thing here. And then we just got to take things away. We got to take the data out of jail. We got to get rid of all the background stuff. And man, some of the things that really bug me, all this implied precision with these extra decimal points, right? Is it 86 or 61.978? No. You know, you need to get rid of all that excess. We're going to line all these columns, put the white space to work. And now I've taken all that ink away and I've made the chart. I'm going to hurry up here, round them more. Actually, just on rounding, our minds can only conceive of 3 digits at a time. That's all you should ever use, right? When we're comparing numbers, that's all we need. All right, we start with this hideous thing that looks like this, and this Zen-like beauty pops up. All right, and now pie charts. Last one. Again, taking stuff away is what we're trying to do. So why would we waste a dimension on a pie chart? It's 2 dimensions of data. Don't use 3-dimensional charts. All right, they actually distort and they take away from it. We get rid of the colors. We just want 2 or 3 colors, 1 for emphasis and 1 for context. We're going to get rid of the wedges. We're going to thicken up those lines, and there we fixed the pie chart. So you see how we do that? You have 3 pie charts to use in your life. Use them wisely. Anything you can show with a pie chart, you can show better with a bar chart. Less is more is the answer. And I always tell people, remember the C anemone, MNE, minimum necessary evidence. That's what you're trying to do with your visualizations. What's the least that I need to show in order to convince? That's how you should do visualization. Lastly, we'll talk about engagement. And I know some of you may have to leave. I'm going a little bit over. Let's talk about color. If clarity helps us make decisions and understand what's happening, engagement gets us excited and makes us an evangelist for whatever thing we're trying to do. You can set the mood with the color. These are all different. There's this beautiful website that looks at movies and the palettes that are used in movies. If you want that warm palette, this is The Life of Pi. Here's the colors that are in the majority of that movie. Here's the Thor movies. These are the color palettes. And notice as I swap through these, how the mood changes. That's what color does. It changes the mood that you're trying to give. Animations are there to create. You need to have purpose in how you do animations. It may be to reduce the complexity of a graph, or it may be to introduce elements one by one. Sorry, I'm not going to have time to show you the animations. And then you can create stories. And this is actually an amazing website. There are 300 million data points in this interactive map. It's called the Opportunity Atlas. Probably the most successful project we've ever done, showing poverty rates in the US using a new measure of poverty. And how do you make 300 million data elements accessible? Well, you create narratives. And what they did is they created these little stories. And if I click on these little points, it walks me through and animates through a story in the data to basically teach me how to use it and to see what's possible. Which at the end of the day, we're trying to get to that interaction. And again, this is a visualization you can interact with, and it's showing suicide rates by year, by age. Each of these distributions shows the suicide rate in that year by age. And you see a very interesting pattern that suicide, and when you interact with it, you'll actually discover this, is that suicide seems to be sticky with an age cohort. Sorry, not with an age cohort. It's not like, oh, wow, teen suicide is really bad now. It's just people who were teens in the 80s struggled with suicide, and they continue to struggle with suicide well into their 40s and 50s. And if you actually push this graph back further, which is how you could interact with it, you'll see that there's another group that grew up during World War II that had very similar patterns as the Gen X group. And so you see these patterns in the data and you discover it because that's not what the headline is. And you own that truth and you become an evangelist for that truth. And so many times when you're creating a data set and trying to convince people, if you can convince them in such a way where you create like a sandbox where they can find their own answer, they can interact with it, those are the people who will truly get it and will base their decisions on it and so forth. Sorry, I rushed through the ending there. I will leave it at that, and I will leave it open now if any of you have some questions for the next couple of minutes.
Daniel, this is outstanding. You have taken a topic that some would consider dry to be very exciting. If you could stop sharing the screen, I'll open up to questions, but I would also like to mention that please do talk a little bit about your company and the jobs that you are hiring for, and then I'll turn it over for questions.
Sure thing. We are currently desperately looking for an experienced UX designer. And it'd be great if they had a background in data analysis or software engineering or psychology or whatever. You know, we're really looking for someone who can talk and also do design. We need someone who has credibility. So if you know someone like that, send them our way. We can give them a great career. They don't have to live in Edmonton, but if they're here, that's even better.
And should they link in with you with that, or?
Yeah, you can email me directly, dan@darkhorseanalytics.com, or you can go to our careers page on our Darkhorse website, and you can see more about the job application there.
Excellent. And Randy has a question.
So I've a comment and a question. The comment relates to what the question will be. And the comment is about, Dan may not remember this, but I'm looking at the dates now. It was April 1st and April 3rd, 2013. And the reason that that's important is that on those two dates, the Edmonton Oilers played the Calgary Flames on those two different days. And we had a Oilers Analytics Group meeting with Dan and I in attendance, and the other officials there were Kevin Lowe and Craig McTavish, whom were the two people that we wanted to do what Dan noted, and that is actually convince them that there were inferences to be made from the data that didn't usurp their value of their experience, but rather augmented it. That's one of the things that we tried very hard to do. Now, the reason that those two dates are important is because at that point in time in 2013, Stephen Lougheed from Calgary was my boss at Alberta Innovates. And he said, how come you weren't at such and such meeting? I said, well, I was at the Oilers Analytics Group meeting. And he said, oh, well, that's probably worthless. And the next 2 days, the Oilers beat the Flames 4-2 and 8-2. And so I told him after that, I said, well, you might think it's useless, but it's working. Now, the important part of that is it's a nice anecdote, but the reality is that all of the model building that you do with the data is an attempt to shift from coincidence to correlation to cause. And the better your model is, the better your predictive predictions matter. And so one of the pieces of work I've been doing of visualization groups around the world is related to what Dan said about interactive visualization. You can just think of 3 or 4, in the case of animation, 3 or 4 dimensions as an interface that you want to be able to play with. Is the interface as good as SQL is in capturing text queries against a database is the question. What we did is made it so when you adjust a visualization, it propagated the possibilities back to the original data and said, if your adjustment of the visualization allows you to draw these conclusions or inferences, then the data that's missing would have to have looked like this. And that's exactly a sort of a story end to end that Dan was telling you. So I guess there was a question in there somewhere. Go ahead, Dan.
Well, I'll just reiterate the hardest part. I always tell our team, I say, getting the right answer is half the battle. Convincing people it's the right answer is the other half. And, any effort spent on that right at the beginning, starting right at the beginning of the project is time well spent.
That's well said. And we are so over time. I will end it on that note, other than saying that, Daniel, the public service that Darkhorse Analytics has been doing with the monthly AI meetups prior to COVID, really hope that starts again. And once it does, we'd certainly be happy, whether it's through Amii, the U of A, I can't really speak on behalf of U of A, but Technology Alberta, we'd be happy to share the information on the monthly meetups, because you were able to get audiences of 100 people in person from in a very cool building in downtown Edmonton to talk about AI, 3 years ago. That's very cool.
It was free lunch was the secret. I'm not going to lie.
Very good. All right. Well, thank you everyone for joining us, and look forward to next week's session and next month with the company that we'll be featuring then. So thanks everyone, and bye for now.
Thanks all. Take care.